wide, you get more air. And then so that the air moving out pushes the robot in the opposite direction. This is the whole magic of zero G, right?
Yes.
You're floating, and it's the equal and opposite reactions.
Right,
So that's how we propel ourselves around space station.
Awesome.
Yeah.
Apollo MG asks, is it gyro stabilized? And what does that mean?
It's partially, quote, gyro stabilized because, you have fans here, and there's actually a fan on both sides, so it's counter-rotating. And what's fascinating is that depending on how fast we spin this, we can change how stable it is in space. So as we do docking, for example, and we want to move in very precisely and very, with very smooth motion, we'll basically spin up the robot, and you can actually hear it get louder. And it becomes more stable because it's using its fans and how fast they're spinning to stabilize itself.
It also gets a little more control authority because there's a little more pressure, a touch more pressure, so it can actually push itself a little bit harder.
Right.
That makes sense. Yeah.
All right. Nice. There keeps coming in
I know. We have one question from Ill Inc. Are robots good for tending the growing of plants in space?
Oh, this is actually a super timely question because, so
good job.
Yeah, 3 weeks ago I went to a NASA workshop on how robots could be used to help grow crops in space.
Oh.
And it's fascinating. You think about all the challenges that would be associated with doing that. I mean, planting and monitoring and tending and harvesting and then processing afterwards.
Yeah.
So I think it's a great area for research and development. Not ready today, but if we want to send humans, especially in the deep space,
of
we
course.
can't just package all the food.
Right.
They're not just going to be eating, out of microwavable things. They're going to need fresh food. And it's a really, as anybody who's grown anything knows, it takes a lot of effort. And so I think robots definitely are needed for that.
Cool.
Some are already being used on Earth to tend crops.
Yeah.
So, yeah.
Yeah, and
to tend and
harvest.
harvest.
There's this whole new interesting category called vertical farming. Where people want to grow really crops inside their homes or their apartments and
in small spaces.
Small spaces, right? Exactly. So
Yeah.
how can you grow vertically? You have all these different shelves and hydroponics that go into help plants grow. But the problem is you still have to take care of the system itself. Things always get clogged. Things need to get harvested. So I think we're going to need robots for that. Definitely.
For that. All right, nice. Here's an interesting one. Phone Things asks, what types of prehensile tasks do robots perform in space, i.e. gripping and grasping tasks? Is that something you guys can speak
we
to?
already talked about the perching arm.
The perching arm, yes.
That can
Aster
grip
V
onto
can
things
grip.
and save energy by doing that. Also, we've been looking at prehensile tasks that a rover, for instance, a wheeled robot can do when it's on a planetary surface. For instance, it can dig a trench, right? If you drive 3 of the wheels and your 4th one, you just you turn it sideways and spin it a little bit differently, you can actually dig a trench. So, for instance, say you want to lay some cables, that you then bury around a habitat. You could use the robot to dig the trenches to put the cables in.
Yeah.
Okay. And that's kind of a gripping task because it's holding on with
no,
the
it's
other
not.
wheels.
There's no gripping. It's prehensile, so there's no.
Non-prehensile.
Oh, sorry, non-prehensile. Yeah,
tasks, yeah.
That's right.
I mean, but in terms of grasping things, we said earlier that Aster B only has an arm for perching, but obviously other systems like Robonaut 2, or even on the Canadarm2 with its Dexter system, has the ability to really reach out and physically interact with things. Maybe you're going to try to unscrew something or to swap out some module which needs to be changed for repair purposes.
Yeah, our gripper is pretty limited.
Yeah, but
they're developing some.
Stanford is actually developing a gecko-inspired gripper.
Gecko-inspired?
For our
Aster B,
perching arm, for Aster B.
Oh, fabulous.
It's already actually on orbit. It launched. Yeah, it just launched. And so they're looking at being able to perch on any surface.
Yeah, it's sort of the universal gripper. I mean, you think about geckos; they can adhere to any kind of surface. This
on the ceiling.
Yeah,
little lizards
they
crawling
really
on
wanna-
the ceiling.
Yeah, not so thrilled about that when they're in your home.
They keep the bugs down.
Yeah, they do. So this new robot hand basically is meant to be the universal thing. So it can stick to any kind of surface, any kind of shape. And that's one of the things that over the next several months we're hoping to see tested with Astrobee.
Very cool.
Yeah.
Ripper. All right. Guess we're going to have to finish soon, aren't we?
Yeah.
Sadly. Do you have a favorite question, or should I throw one out there?
You go first.
Okay. Pollo Hernandez asks, how could you perform real-life tests? Parabolic flights, perhaps? That's nearly testing like with punch cards cost-wise. Well, how do you test these space robots on Earth?
So Astrobee, we tested on a granite table. It's kind of an upside down air hockey table where instead of the air coming out of the table, it comes out of a puck. And the robot sits on top of this puck.
Oh, okay.
So it floats on the puck.
Oh, right. So it's able to slide around.
It slides
smoothly.
around. It's like a frictionless surface, so it can simulate what it's like to fly around. Unfortunately, we can only do 2